Hello everyone, I am Dr. Anil Mangla. Today I will explain the topic of graphical explanation of dy by dx. What is dy by dx? Dy by dx is basically we read it as derivative of y with respect to x. And to understand this, uh, I, I will we need to use a sum function which is represented here, and in this axis is y axis, as most of you must be knowing, and this is x axis. Okay, when we say y as a function of x, so here x is a independent variable and this y is a dependent variable, and we return y is a function of x. Okay, so before understanding this dy by dx, what we need to understand the slope of the function. Let's say I want to know the slope or the average slope of the function between 2 points. Let's say x equal to 2 to x is equal to 6. Okay, I want to know, evaluate the derivative or the slope of this line which is joining the point x1 y1 and x2 y2. Okay. So what this slopes basically tells me? Slopes tells me the, okay, let me use the slope basically tells me the change in y, with respect to the change in x. So how much y or the function value has changed, which is represented by delta y, where delta y is equal to y2 minus y1, right? y2 minus y1. This is this perpendicular distance here, vertical distance here, is telling me how much y is changed over a given change in x, that is x2 minus x1. So to find the slope of, let's say, this line PQ, which is basically the average change in y, average change of this function over the given interval of x, that is slope of PQ. That is, so what is the average change? Average change is y2 minus y1 over x2 minus x1, which can be also written as change in y over change in x. So this is an average change of this function over this given interval x2 minus x1. Why I'm using word average? Because this is an overall change over this. But if you look at these small intervals, this change is different. Okay, when we add all these changes and then divide it by the total number of intervals, we will get the total change in the, or the average change in the function y is equal to fx over this interval x2 minus x1, and the change is given by y2 minus y1. Okay, there was an error here, it should be y1. Okay, now this is slope of function, slope of this function pq, slope of line. This is a slope of line pq representing change in function. Now if I keep on reducing this distance x2 minus x1, what will happen? Let's say I reduce this to these 2 points. Okay, so my delta y, change in y, will also reduce with respect to x. Now think of the limiting value. Limiting value means when delta x approaches 0. When this delta x is approaching 0, this change in x, when it will be approaching 0, then it turns into a small point. Okay, that is and there will be a very small change, corresponding very small change in x. So I would like to show you that with this by zooming that point. So this point after zooming will look like this. So this is delta y, change in delta y, and this is change in delta x, where delta x is approaching 0. Okay. So then at that point, when this delta x approaches 0, then delta x is named as differential x. Okay, differential change in x, and the corresponding change in y is called differential y. This is called derivative of y with respect to x, and this is basically a slope of a line at a given point. This is a slope of line at a given point, and when we draw a line at a given point, then it is called tangent, right? Then it becomes a tangent to this curve at a given point in which we are about which we are interested. Let's say x naught y naught. So basically dy by dx is a slope of tangent at point x naught y naught. Okay, it basically tells us what is a differential change in function at a given point. Okay, and this dy by dx is basically equal to, now limit delta x tends to 0 del y by del x, which is basically limit delta x tends to 0. This is delta x here, and this is function value at x plus delta x minus fx. This is a function value at a small increase, delta x increase. So this is a small increase in function fx plus delta x, and this is a value at function at a x. So this change gives me delta y over delta x. So basically this is the first principle of derivative. So dy by dx, which is rate of change of y or the change of y function with respect to x at a given point, is equal to limit delta x tends to 0, the small change in the value of function at x plus delta x minus fx over the change in the interval delta x. So I hope this explanation about the graphical representation of dy by dx maybe must be helpful to you in understanding and appreciating the derivatives further. So I will be ending this. Thank you.